This video is a continuation of the data frames notebook, and we're going to be discussing concatenation of data frames. Concatenation of data frames is handled similarly to matrices. In fact, we use the same Cbind and Rbind functions to do this. These common functions will actually output a data frame if at least one of the input arguments is a data frame. So we can append columns to an existing data frame by writing Cbind and then passing, say, our data frame df. And then maybe in this case, I want to add a new column of integers using a sequence from 10 to 6, and I give it the name m. Notice that I didn't have to first create a new data frame to hold this sequence. Instead, Cbind is smart enough to know how to merge different types of objects. However, one thing to note when using Cbind is that you should make sure that the number of rows in all of your arguments match, otherwise R will issue an error. Also, any row names that appear in the output of Cbind will come from the first listed object that actually contains row names. So Cbind is not going to attempt to merge row names that appear in multiple arguments or anything like that. So you should be aware that this behavior is present since Cbind doesn't issue any warnings or errors when it finds multiple row names for the same row. Now, Rbind, on the other hand, is typically used to merge existing data frames. But just like Cbind, this doesn't have to be the case, as long as the number of columns match across all arguments. So let's say we wanted to use Rbind to add a new trial to our data frame df. And so we write Rbind, df, and then we're going to give it the name trial6, and we'll assign to trial6 a vector containing the string f, the integer 6, and the double 32.1, matching our previous three columns x, y, and z above. If you're wondering, in the previous example, we did not assign the output of Cbind to df, so the column m exists only in the output above and is not currently in the data frame df. And so when I run this code block, the vector of data passed for trial 6 had the same number of elements as the number of columns in our data frame df, and so of course we received no error. But notice that the types of our columns y and z have changed. Previously, y was of type integer and z was of type double, and now both are of type character. So what's going on here? Well, if the appending of rows would result in a column having multiple types, then the Rbind function will actually use the more generic type to convert and store all the data in that column. In this example, we created a vector from a string, an integer, and a double. However, vectors can only contain one type, so the same conversion was actually made upon the creation of this vector, meaning that all of these values, even though they appear to be a string, an integer, and a double, were converted to type string. Thus, when the Rbind attempted to append this data to our data frame, it was forced to convert the last two columns to type string, since string is the more generic of the types involved. If you wish to see the hierarchy of types and how they'll be changed during this type of operation, check out the built-in help page for Rbind, and then scroll down to the value section. Now, since we obviously don't want everything in our data frame to be of type string, we can actually avoid this type of mistake, first by being aware that these types of conversions do occur, and then second by ensuring that we're using the correct data types to begin with. For instance, we really should have used a list as the second argument to Rbind, since the list can store multiple types of data. So instead of using the C function, I'm going to replace that with a list, and we're going to run this and see what we get. In the output now, we see that we no longer get strings for the column types of y and z, but the y column has still been changed from integer to double, and it's not quite what we want. In previous examples, we've seen the asInteger function used, and we're actually going to use that now to ensure that the value 6 in our list is stored as an integer and not a double. And now we see that the column types are as we expect. Now, when you're getting started with these types of operations, type changes can occur and often will without a warning. So it's a good habit to verify and test that all the operations you're performing have the desired effect and result in the desired data structure. Now, another issue to be aware of when appending rows is that row names will actually be modified if duplicates are detected. So to see this, let's create a new data frame. This new data frame will contain two new rows of data for the x, y, and z columns. Each of these will be of the correct type. Notice, however, that I'm using the row names trial 4 and trial 5, which we do already know exist in our previous data frame df. And we will now use rbind to create a new data frame containing both the rows from our previous data frame df, followed by the two new rows in the data frame df2. And we look at the output here and we'll see that the last two rows, instead of being trial 4 and 5, are now trial 41 and trial 51. Rbind, in an attempt to fix the duplication, actually appends an integer to the duplicated name and increments it for every duplication of that name. Hence, we got trial 41 and 51 in this example. If additional instances of trial 4 or 5 appeared, we would have trial 42, trial 43, and so forth.